This is Odum Maths. Today I want us to look at some few examples on indices. Okay, so we are told to simplify each of the following. So the first one is into brackets 3a b squared all to the power b, l to the power 2, times 27a to the power 6b times into brackets ab all to the power negative 1 divided by 81 a to the power 4 b to the power 3 times 3a squared b, that is a, then b 125 p to the power 4 q to the power 5, then times into brackets 5p squared q all to the power negative 3 divided by p squared p to the negative 2 q to the 4 times pq all to the negative 1, then c x to the negative 2 yz all to the power 3 times x to the negative 3 yz all to the power 2 all over xy squared z all to the negative 4 times x cubed yz all to the negative 1. So let's see how we can tackle this example. Okay, we can write each of them with this one. It means that this is to the power 2, because this, the third law, should multiply whatever power inside. So a to the power 2, b to the power 4, that is 2 times 2, 4. And then this is 2 times 1, 2. This is 2 times 1, also 2. Okay, times, we can write 27 as 3 to the power 3, then a to the power 6, b, then times, this is also a to the power negative 1, b to the power negative 1. Okay. Now, let's continue. Oh, then, divided by, we can also put 81 as 3 to the power 4, then a to the power 4, b to the power 3, times 3 to the power a squared, or 3 to the power, 3a to the power 2, then b. So let me put the numbers 3's on one side, 8's on one side, and then b's on one side. So that is going to help me to get the answer so easily. So 3 to the power 2 times 3 to the power 3, 3 to the power 2, 3 to the power 3, this one, divided by 3 to the power 4, and then times 3, times a to the power 2 times a to the power 6 times a to the power negative 1, then over a to the power 4 times a to the power 2, then times b to the power 4 times b to the negative 1, divided by b to the power 3 times b. Okay, so this is going to be, this is 3 to the power 2 plus 3, which is 5, divided by 3 to the power 4 plus 1, which is also 5, then times a to the power 2 times 2 plus 6 minus 1. So 2 plus 6, 8 minus 1, 7. So a to the power 7 over a to the power 4 plus 2, which is 6, times b to the power 4 plus 1 minus 1. So b to the power 4 over b to the power 3 plus 1, so which is also 4. So we have this taking care of this one. Then this also taking care of this one. So we have a to the power 7 minus 6. That is the same base divided. So we subtract out. So the answer is a. Okay, so simple. Okay, now let's look at the second question. That is 125 p to the power 4 q to the power 5 times into brackets 5p squared q all to the power negative 3 divided by p to the negative 2 q to the 4 times pq all to the negative 1. Okay, now let's see. So here, because of this 5, now when we are working in indices, or we are working in indices, and we have numbers that are more than 10 or more than 4, 5 going. To reduce that number, think of getting a prime number with a certain power that will give you the number, the original number itself. So example, this is 125. The only prime number we can think of is 5. And we have 5 already here. So how many times are you going to raise 5 to a certain power to get 125. How many times? So that is going to be 5 to the power 3, which will be 125. So now let's see. So this is going to give me 5 to the power 3, p to the power 4, q to the power 5. Then times 5 to the power negative 3, p to the power negative 6, q to the power negative 3. That is, this into this time, this becomes negative 3. 1 times the 5 here, third law. Then 2 times this one is also negative 6. Q times 1 is also negative 3. Okay. Now let's look at the denominator. So p to the negative 2, q to the 4 times, this is p to the negative 1, q to the negative 1. Okay, so now let's group the numbers from the variables separately to get the answer easily. Okay, so we have 5 to the power 3 times 5 to the power negative 3, then times p to the 4 times p to the negative 6, p to the 4 and then p to the negative 6, divided by p to the negative 2 times p to the negative 1, times then q to the 5, then times q to the negative 3, all over q to the 4 times q to the negative 1. Okay, so this is 5 to the power 3 minus 3, which is 5 to the power 0, and any number to the power 0 is 1. So this will go away. So we have p to the power 4 minus 6. That is the same base multiplying, you add. So that is 4 minus 6. Divided by p to the power negative 2 minus 1. So negative 2 minus 1 times q to the power 5 minus 3, 5 minus 3, that is adding, over q to the power 4 minus 1. So 4 minus 1. Okay. Now, this is going to be p to the power negative 2 over p to the power negative 3. Negative 2, negative 1 is negative 3, and then this is negative 2 times q to the power 2, that is 5 minus 3, so 2 over q to the power 4 minus 1, which is 3. So that is p to the power negative 2 minus negative 3. That is, they have the same base dividing, so we subtract powers. So negative 2 is already there, and then because they are dividing, minus, then there's negative 3 also here. Okay, then times q, also 2 minus 3. Okay, now this is going to give me negative 2 plus and minus negative 3 is negative 2 plus 3. So p to the power negative 2 plus 3, which is 1. And then q to the power 2 minus 3 is also negative. So p q to the negative 1. And this is the same as p over q. So this is the answer. Okay. Okay, let's look at the last of the questions. So here, like we did for the first two, we are going to do the same thing here. So this is going to give me this, and this becomes x to the negative 6, then y to the 3, z to the 3, times this is also x to the negative 6, y to the 2, z to the 2, divided by this is x to the negative 4, y to the negative 8, z to the negative 4. Hope you are following. So this time, this is negative 8. This is having 1 times negative 4 is negative 4. And then this is also having 1 times negative 4 is negative 4. Times, then here, this and this becomes x to the negative 3, y to the negative 1, z to the negative 1. So x to the negative 6 times x to the negative 6, then times y to the 3 times y to the 2, times z to the 3 times z to the 2. Okay, all over x to the negative 4, then times x to the negative 3, then times y to the negative 8 times y to the negative 1, then times z to the negative 4 times z to the negative 1. Okay, now let's see. This is negative 6 plus negative 6, which is negative 6 minus 6. So that is x to the negative 12. They have the same base and multiplying, so you add. Negative 6 plus negative 6 is negative 12. Then this is y to the 3 plus 2, so which is 5. Then times z to the 3 plus 2, which is also 5, all over. Now this is going to be negative 4 plus negative 3, which is x to the negative 7. Then y negative 8 plus negative 1 is also to the negative 9. Then z negative 4 plus negative 1 is negative 5. Okay, so let's see if we can have some. So this is going to be x to the power negative 12 minus negative 7. So they have the same base and dividing. So negative 12, then because they are divided, minus, and then negative 7 is also here. Then y is also 5 minus negative 9. Then z is also 5 minus negative 5. Okay. So this is going to be negative 12 plus 7. And negative 12 plus 7 is negative 5. So this is negative 5. Then y, this is also 5 plus 9, so which is 14. Then z, 5 plus 5, so that is 10. So this is the answer to the last question. Please don't forget to subscribe, like and share this channel. The name has always been Odum Maths. On TikTok it is odum.maths, and on Facebook it is Emmanuel Odum. Thanks for watching. Bye.